Hello, thanks to all of you who have stayed through the end, and thanks to Rudy and Schwartz for putting on the event. And thank you to all of my panelists here today. Thank you so much, it's good to see you. So obviously we have Wilhelm, we have Russell, and Charlie. And I think that we probably have a pretty good sense from the presentations that all of you have done. But I'm wondering if we can start out with just a little bit of an acknowledgement that 5G is a marketing term more or less at this point, since we don't actually have any standards in place. And let's just take a few brief moments each to talk about what you consider 5G technology, 5G systems. Each of you have touched on this in different aspects of your talks, but let's recap. So Charlie, you want to start?
Sure. So, I mean, 5G is here today. As I mentioned, we already, it's been a while. I mean, when we started, there's a lot of discussion on what is 5G, whether it's a marketing term or whether it's really technology behind that. But I think at least with the decision on 3GPPs to start working on 5G, it gives it really the, the definitive answer that we are going into the 5G study. I mean, yes, we do have to start this discussion a few years before the standard is actually there, because that's just the nature of the standard process. It does take a few years to realize that. But I'm happy to report that we are planning to start technical work on that this year.
Yeah, so I mean, to a degree, 5G is a marketing term because it hasn't been definitively defined, but I agree. It's coming, it's out there, we know it's in the future, we just have to massage it to see exactly which way it's going. So, one thing that I see is we've got to get to the higher data rates, the demand is there for that, and maybe even more importantly is the capacity function, because that's really what's going to drive the finances. From the providers, they're going to see more users out on that network. They need to support the capacity in order to get the funds, to get the money from the consumers. So it's definitely going to be pushing that area, and now it's just really a matter, as we talked about, that the standards are going to be defined, how we get there to get that ultimate goal in realization.
Uh-huh.
Yeah, for me, 5G is everything 4G cannot deliver today. And we already heard a little bit about the requirements. And for me, 5G is low latency, which seems to be very important. It's massive machine type communication, sensor stuff. It's also ultra reliable communication, smart grid and all that stuff. And last but not least, it's very high peak data rates, and this is a region where millimeter wave probably will take place.
Okay. So let's take a step back and recognize, I think, that actual network deployments are just really starting to hit LTE advanced. Carrier aggregation, for instance, is only deployed in a few networks, a few locations. It's far from ubiquitous, especially here in the US, for one. Is it too early for the industry to be putting so much effort into 5G? And can you each talk a little bit about why now? Yeah.
I can start. It's a very good question. So why now? And you mentioned carrier aggregation. So I'm just searching my memory to see when we started the carrier aggregation discussion. I think I found the answer. We started carrier aggregation discussion in 2008, March. I still remember that meeting because it's in Shenzhen meeting. It was in Shenzhen, China when we started that discussion. So from 2008 to maybe the first real deployment, which is probably 2014. So it takes about 5-6 years for these big features to go through the process, to go through the IoT test, so that we make sure it's working from end to end, and to then we can have a real deployment and commercialization. So it does take time for, especially in the cellular world, because the technology is very complex and involves multiple parties. So that's why it's important for us, if we are shooting for the target of initial commercialization of 2020, this is the right time for us to start investing and build the necessary technology.
Yeah, absolutely. The time is now to start. It's going to take a long time to get there. And I remember, I don't know, this may have been like 2005, I was working on WiMAX systems, and that was going to be the next 4G platform. And then in the back of the mind, LTE, they're defining it, 3GPP is starting to work on that kind of stuff. And it takes, it takes 5, 6, 7 years before everything comes to fruition, from getting the standards completely defined to getting the providers and semiconductor devices like ourselves and the OEMs to be able to develop these systems. So the way I see it now is, now that the standard is starting to get defined, the clock is sort of officially ticking. I mean, we've been talking about it for certainly the past year to 2 years, but I think once that standards body is in place and really sitting down at the table to start making things, put them down on paper, the clock really starts ticking, and we've got about 6 years before this thing really comes to fruition.
Well, any thoughts?
Yes, I would totally agree to previous speakers. So it takes a long time to develop a new standard. And as far as I know, worldwide scene 3G is still ramping up. And I think for 4G deployments, the maximum is expected around 2020. So everything takes a long time, and we have now to start thinking about the next generation. Makes sense.
Okay. There are different opinions across the industry as to whether 5G will serve as a complement to 4G and LTE advanced systems, or whether 5G will be ubiquitous. The GSMA, for one, has been collecting white papers on 5G, and we have folks like Nokia. A Nokia white paper described a user situation in which there will be, quote, only a few users per cell for which 5G requirements need to be fulfilled at any given time. Ericsson said in a white paper that the high frequencies, quote, can only serve as a complement to lower cellular frequencies, which will still support the bulk of traffic, in Ericsson's opinion. So for my panelists, do you think 5G is going to be a complement to LTE advanced 4G technologies? Do you think it's going to be ubiquitous? And why? Charlie, go ahead.
Yeah, so that's probably, that debate probably started not from only 4G and 5G, but we heard similar debates, 3G and 4G and so on. So it's always like this, right? If you look at how things work, when you start a new generation, new deployments, typically the starting point will be not so many base stations. The coverage is relatively small, so you're not going to throw away your existing infrastructure. So definitely it will work together peacefully. And it'll be probably a smart thing to do for operators to make use of both existing infrastructure and the new 5G infrastructure, at least for a long period of time. Okay? Because as you mentioned earlier, 4G and 3G, even 3G we are still using today, right, to provide necessary coverage when you don't have 4G coverage for LTE. But as time goes on, I mean, that's also already happening today in the industry. Some of the 2G or 1G spectrums are being reformed by the operators to make room for new technology. So I think similar situation will happen again. We will go through a period of time of transition where LTE and 5G will work together very seamlessly to provide both coverage and opportunistically capacity as well, if you are in the coverage for those 5G cells. But then as time goes on, as the coverage of 5G becomes more complete, then you'll see more and more operators will choose to probably sunset some of the earlier generation spectrum and technology, make room for the new technology.
Yeah, I mean, there's still 2G systems out there today. There's GSM carriers that are still operating in the world, and there are even a small new deployments in 2G. And then we've got 3G deployments and 4G deployments, and I see it's just going to add to the mix, right? We're going to add 5G into the mix. It'll start off slowly, and then older stuff gets phased out and newer stuff gets phased in. You know, those quotes that you gave, I remind myself of many years ago when, the cell phones were just coming out and they had phones on them. I mean, they had cameras on them. And I'm like, why do I need a camera on my phone? That's ridiculous. I've got my own camera and I'm never going to use this. But, now what do? That's the only camera I have now is what's on my phone. So the services are going to be there that are going to demand the features that 5G is going to provide. And we can't even see all of it today. But as time goes on, we're going to get visibility to some new things that we never even thought of before that are going to demand that kind of service.
Yeah, in my understanding, 4G will also be a part of 5G. That's some definition. I think it's from the Metis project that 5G is a system, basically a system of systems, and this is quite obvious because you have so many different requirements. So if you're talking, you will not have one radio access network technology which covers all these requirements. So if you're talking about ultra-reliable communication with very low speed, then it will be something different than this high-speed millimeter wave stuff. And so there's also some room for 4G type communication within, because for certain requirements 4G is great and not much to improve, but all the other topics, all the other applications have to be improved, and that is the place where 5G comes into play. So it's, yeah, for me it's 4G isn't part of 5G, and this question is not so severe. Yeah.
Okay. So many of the features of 5G that each of you mentioned in your various talks, massive MIMO propagation, limitations of millimeter wave, seem to indicate that very high frequencies will require substantial network investment and very different device design probably than we've seen in 2G, 3G, 4G cellular systems. Now, Charlie, you had some great pictures and some actual evidence of work that Samsung has done in this area. I'm wondering what each of you think 5G base stations might look like, what we might see in terms of user equipment.
So I think what we're going to see in that department, it's going to be a hybrid of some of the new technologies like Charlie was mentioning in the higher frequencies, but also utilizing the license bands that are available now. He mentioned a lot of the complexities that are going to be difficult to solve, power amplifiers and the efficiencies thereof, the propagation delays. So I don't think it's going to be all in that space because there's still spectrum available within the less than 6 gig area, and we can utilize that. And we can start to utilize it more effectively with some of these carrier aggregation techniques, and we can start using stuff in a little bit in this band, a little bit in that band, a little bit in these other bands, and then we can augment that with opportunities to go even into the higher frequency bands. So I sort of see it as a hybrid network in order to facilitate that kind of a realm.
Well,
I would totally agree to that view. Yeah.
Okay. So while the amount of spectrum available at higher frequencies and the channel sizes are desirable, is that going to be sufficient to motivate 5G investment? Can you talk a little bit about what makes a compelling business case for 4G? Because all of you more or less have pointed to the engineering challenges that are involved in utilizing the spectrum. Just the fact that the spectrum is there and there's a lot of it, is that enough to drive this?
Well, I think ultimately what's driving it is not the spectrum and technology alone, right? What's driving it is a use case and a need, a demand for the broadband data rate. As we have seen many predictions, right? We are seeing this compounded growth of data traffic every year, and comparing, for example, 2020 to maybe 2012, some prediction was saying we need 1,000 times more data capacity to support the need of those growth. And that's one area of growth, right? To argue for the case of 5G and investment, but there's also other unique applications where 4G simply cannot do it today. For example, as we heard today, right, the low latency type of applications, remote surgery, remote operation using robots, and massive connectivity. For example, having 500 billion machine or sensors across the world to assist us in many different ways. Today's infrastructure simply cannot handle that type of scale and latency. So that's why, if you think about some of the future growth areas, future vertical markets that we cannot conquer today, there's a lot of opportunity that also calls for the investment today on these 5G technologies.
Yeah, as I kind of mentioned before, we know 5G is going to be pushing these data rates to higher speeds, but from a commercialization or a finance perspective, I think it's going to be the capacity issue that's going to be driving the providers in order to demand these new services that 5G is going to provide. So, you know, you as a consumer, if I said, hey, I'm going to juice up your data rate, you know, from what you've got today to 1+ gigabits per second, you know, you're going to pay, you know, 50% more for that service, and you'd probably be like, no, I mean, I don't really need it, I'm kind of okay, that kind of stuff. But when users getting dropped and you can't get more users on the network, and these provider guys are saying, wait a second, I need something, I got to get more users in here paying the bills, they're going to be demanding that from the OEMs, and then that trickles down to the rest of the industry. So to me, that's going to be the driving force from a commercialization perspective, but then that's going to open up all these other neat things, you know, the machine-to-machine communications, certainly the higher data rates and what you can do with that. I mean, now you can be streaming video and TV and movies and all that kind of stuff. That is just going to fuel the demand from the consumer even more, which, again, brings us back to a capacity situation.
Wilhelm?
Yeah, with respect to the peak data rate and capacity discussion, I think it's not a question of motivation. So the operators do definitely have no other choice than to invest in infrastructure to satisfy the increasing demand, even if the forecasts are not as bad or as strong as they are given. It is obvious that we run out of spectrum for mobile data transfer. So in this case, we don't have any other chance except for investing in some other infrastructure. Of course, we could also squeeze out the existing technologies more and more, which is, of course, done with massive MIMO and all that stuff. But at the end of the day, we also need to have some other techniques like millimeter wave.
Now, one of the other things that I want to circle back to that I think all of you mentioned in one form or another is the issue of power, power consumption, and different aspects of power. There's some talk I've seen of small cell deployments that could power down when not in use. I think that's even being considered for LTE advanced, not necessarily considered a 5G characteristic. You know, so you have a shopping mall, it closes for the evening, you can power that deployment down until it's needed the next day. Also seen indications that device-to-device links may reduce overall power use. Considering a millimeter wave propagation characteristics and the perspective that each of you comes from, how do you think the power use of 5G will compare to 4G systems, and what are some of the issues surrounding that?
So, yeah, that's the very, very important area indeed. How do we improve the power efficiency? I mean, one of the pain points, at least for me as a consumer, and I'm sure for many of us here in this room, is how long does your phone last with one charge? So that's probably a problem of our time. That we really need to find a solution to make this last more than a day or half a day going forward, especially in the face of the much higher data rate that we expect to put in these phones going forward, right? You know that with more data rate, naturally you will require more power. So there's a lot of research that's needed, both from the base station side as well as from the hardware terminal side that need to go in there to improve the power efficiency as well as improving the system design. So as I mentioned in some of the slides, that typically there's a life cycle of technology evolution, right? So hardware can evolve at its own pace, but we can also do some work on the system side, knowing that there's some limitation from there. How do we take those into account and build a best system possible at every step of the way? So there is a lot of work to be done, and at the end of the day, I'm still hopeful that we will be able to deliver a phone to every one of you that can last more than what we do today.
Russell, from the chip side?
Yeah, so I mean that's one aspect is the mobile device, the phone that you have in your pocket. But you look at it from, let's say, the base station perspective, which is kind of where I'm seeing things from. A lot of times people, base station, who cares? We don't care about power, efficiencies there. But you see that as the techniques are going to be putting into these beamforming antennas with these arrays, you're going to be cramming, each one of those elements has a transceiver behind it. So you're cramming a lot of transceivers that are going to be in close proximity together. And there is just a physical limitation there from an efficiency perspective because those things generate heat. You got to get the heat out of it. Even in base stations today, just thermal management is one of the highest cost elements, and it's going to continue to be that case because you're going to be cramming more elements into a smaller space. So the shift, I think, is going to be interesting because there is going to be a little bit of a shift towards, instead of the huge macro base station being proliferated everywhere, I think there'll still be some of that. You're not going to get away from that completely. But there's going to be a migration towards a lot smaller cells or smaller transceivers that feed these, beamforming antennas and the like. So now the efficiency target is not, hey, we're not going to try to build this 40-watt PA with 400-watt peak capability, which is what you see in base stations today. Now they're going to be probably an order of magnitude lower radiated power, but more of them. So you still have the efficiency problems to deal with, and you're not going to have a lot of the traditional linearization techniques that you have today, which is like right today, it's digital predistortion is the prevalent technique. But there's a lot of overhead with digital predistortion, and that's fine if you're going to build one really big PA, but if you're going to build lots of smaller PAs, it's not quite as efficient to do that kind of a technique. So I see this as really being an area where there's going to be a lot of new research going on to try to figure out ways to linearize, increase the power amplifier efficiency on the base station transceiver side, and be able to cram those in and keep the thermal under control.
Wilhelm, thoughts
Yeah.
on power?
Yeah, I would agree that this is a very important topic, but during the last years it was also discussed a lot. There was this Green Touch initiative where with the goal to reduce power in mobile communication. And it also depends on the definition of the power consumption. So from a scientific perspective, of course, it is good to have very dense deployments with very small cells, and also do some beamforming, because then you reduce the transmitted power, and you would also reduce the overall transmitted power, and this is efficient somehow. But you do this on the cost of higher complexity, and if it comes to the digital baseband, then you probably burn up all the advantages. But so you have to be carefully about the methods how to measure power. But at the end of the day, as we have heard in the previous talks, so especially millimeter waves are nowadays not very critical with respect to efficiency. Power amplifiers falling far behind the legacy bands. So it's a very important topic, and much work to do.
We're going to have to figure it out.
Yeah.
I'm going to ask another sort of a specific question about how backhaul. We're going to deal with backhaul. That's consistently a pain point in cellular systems, and as we move to LTE, LTE Advanced, that's definitely been a bottleneck in the networks. With much higher data rates and all of that goes along with that, how do you think, or what are some possibilities for handling backhaul in 5G systems? Charlie, you want to go ahead?
Sure. That's a very, very important area. In fact, small cell has been developed for quite a few years, starting from LTE release 10. So it's been 5-6 years. Deployment has been quite kind of slow. Yeah. The main reason is the limitation on backhaul. Sometimes it's really just very difficult to get the fiber or copper that's needed to connect those small cells. So going forward in 5G, I think this problem will continue, but I think one area that we see some hope is especially going to the millimeter wave, because the bandwidth is large and nature of this channel allows you to do better beamforming technology. So you will have a lot better chance now to actually to do in-band backhauling. So the same spectrum can be used to allow you to do both backhauling as well as access channel. So we have done some work in this area. We see a very promising kind of solutions that allowing us to do in-band backhauling, and we think that could be a very good solution going forward. I mean, among other things that's out there. Yes, but indeed, this is a very important question or challenge to be addressed going forward.
Wilhelm, I'm going to ask if you have thoughts on 5G backhaul. You've done the channel sounding work, and I'm curious as to what your perspective is on using that as either backhaul or in-band backhauling.
So we did no specific research about in-band backhaul so far, but yeah, it depends a little bit on the situation. So especially in Europe, where you do not have much fiber, so you have to rely on wireless backhaul, and in my opinion, this is also one reason why small cells did not take off so far, especially in Europe, because you have to find a solution. Of course, millimeter waves would be appropriate, but then you may have the problem that you have to mount something like dishes on lampposts, and people do not want to have this. And if you are talking about a meshed scenario where you have multi-hop from lamppost to lamppost, so you would have to apply multiple dishes. And so you end up with some beamforming techniques, and then we are back to the same technologies which are also important for millimeter wave access, as discussed in 5G. And so, at the end of the day, both things maybe converge, and so we are at the in-band backhaul point. So I think another issue is what we didn't have talked so far, that also the data rate on the backhaul is supposed to increase massively, because backhaul is not seen anymore as just a pipe for IP traffic. So it comes to centralized RAN architectures or cloud RAN architectures, then you have to transmit a lot of more data, factor of 10 or so more, and then even fiber may becomes a problem in terms of power consumption of the transceiver. So this is, of course, a very important topic now, and especially for 5G.
For the foreseeable future. Russell?
Yeah, I mean, I agree. It's a difficult problem. We start talking about these increased data rates. There's not an easy solution that's out there. My thought is that that is the area where the millimeter wave can really shine, because you do have that unobstructed bandwidth at your disposal, so you can really push a lot of information through that bandwidth. And it's going to have to be, but it's really a paradigm shift to some degree from backhaul situations as they exist today. As they exist today, they're basically line of sight microwave links. And now you're talking about something, of course, obviously at higher frequency ranges. You're talking about now employing basically a non-line of sight, kind of a cellular infrastructure, as these guys have just already mentioned. So now you got the same kind of things that are going on with antennas and beamforming and that kind of stuff. But certainly the millimeter wave frequency space to take advantage of it, since that is wide open spectrum, to me, seems like the likely place to target.
Okay. I have a few more questions for you, but I also want to open it up to the audience. And do you guys have questions for our panelists? Oh,
Nope.
We've got one down there. I know we didn't have time after each of the presentations, so if you have presentation-specific questions for these guys, make sure you ask.
Thank you. Keith Radowski, CTO at Quintel. Question is, I haven't heard much about the physical size of some of these products that go on top of the towers with the 64 elements and 64 radios. And if I do the math, it's a refrigerator. Any comments?
Charlie, go ahead.
I guess that's a function of the
frequency
that you're looking at. So especially for millimeter wave, for 30 gigahertz, the wavelength is 1 centimeter, right? So 64 antenna, if you organize that into 2D array, 8 by 8, roughly speaking, that will be only about 4 centimeter by 4 centimeter. So it's about this big for antenna. And a lot of times things are limited by antenna form factor. So of course, maybe a little bit bigger than that once you put in RF front end, ADC, and so on. But by and large, I think antenna footprint is the biggest chunk in the whole base station design. So you can see that it's not going to become up what you're thinking about going forward.
Okay.
Well, we're relying on your company to solve that problem for us. So.
All right. Well,
There
thank
you
you.
go, Keith. You got some homework.
More questions? I got one. So most of the designs that we have today are CMOS based, right? And I want to provoke the panel. So is millimeter wave killing CMOS and we move to gallium arsenide, and do we have the fabrication techniques for that, or is it still CMOS based? What's the panel's opinion?
Russell, do you want to jump on that?
Yeah, so there's actually been some advancements in CMOS. So CMOS is not dead, it is not dying. We're pushing CMOS into the realms of 80 to 100 to 100 plus gigahertz. And I mean, it's still kind of blowing my mind that we're pushing it to those kind of frequency levels. But no, that's definitely one of the areas that's being heavily researched because of a lot of the advantages, certainly from a cost perspective, of CMOS compared to gas or other exotic materials.
Other questions? We've got Emil over there.
You're not letting me done my exercise today, so running back and forth.
So what are you guys doing for research with regards to different modulation techniques? I just saw last month NGMN released their 5G guidelines, and they basically said OFDM not allowed in 5G. And so they're looking at wave amplitude modulation, faster than Nyquist. Are you guys looking at what the potential modulation will be used for 5G?
Charlie, go ahead.
Yeah, that's a very good question, yeah. I'm not sure if I read that document the same way as you do, but there might still be room for OFDM. But indeed, I mean, OFDM has been around for many years, and it works very well in LTE. But going forward, there's a few reasons that we need to think about new solutions. I mean, as I mentioned, one of them is the power efficiency. OFDM typically requires 7 to 10 dB of backoff. So it's very difficult for us to reach the same PA efficiency using OFDM. But if you change that waveform, then it's possible for you to operate much closer to the peak efficiency. So that's one reason. The other reason is the overhead. OFDM does require cyclic prefix, right? As I mentioned, once you go to the higher spectrum, the bandwidth becomes very large. Then the percentage of the CP compared to the symbol becomes too big. So that's another reason that we are looking at different waveforms. We have done some research in those areas, I mean, exactly to address these two issues.
Yeah, I would say there's also another issue with OFDM and millimeter wave that is sensitive to phase noise, and usually phase noise is higher at higher frequencies. So this might also be something which has to be taken into account. Yeah, so it's open for new waveforms.
Okay. Another question for our panel. So we've seen LTE lead to some convergence. We don't have the GSM CDMA split that we did in 3G. But there continues to be fragmentation in terms of spectrum bands. You've got 40 plus bands when you talk about a global basis. Do you think that 5G has the potential for greater convergence, greater fragmentation? What are some of the possibilities there?
I think it's still more fragmentation. It's the existing bands that are here today, those aren't going away. If anything, we're adding more to them, and we're trying to open up some new bands that we already start to see with opening up the 5 gig Wi-Fi bands as being part of the standards. So yeah, the fragmentation I don't think is going away. What I think will happen, though, is that we're going to be more adept at utilizing that spectrum more efficiently.
Other thoughts?
I would agree.
Yeah.
Okay.
Probably.
Will the government auction off spectrum like they do today? I mean, if I just take the AWS free auction, right, where potential carriers had 5 megahertz of spectrum, paid like $10 billion for it. So if I'm the financial secretary, say like, okay, I give them now 2 gigahertz at 70 gigahertz carrier frequency, so that's like times how much money is that, right? So what are your thoughts on that one? Will that be based like on things like dynamic spectrum access, that every operator uses 60 gigahertz when they need it? Is that really like organized in blocks and then auctioned off? How are we going to do that?
I mean,
Thoughts on spectrum management?
probably I cannot speak for the governments, but you know, if I look at from a technology perspective, I think there is still a role for those dedicated spectrum to play in order to serve those you know, farther out users to reach the coverage that you intend to have for a macro cell or even a small cell, but with 200 to 300 meter of coverage that we are thinking about for 5G system. The problem of those unlicensed bands is you are limited by how much power you can transmit and also the interference around you. So yeah, in our view, that there is still a role for those dedicated license. Maybe spectrum sharing could be part of a solution as well, but you know, at some point you still need to allow this higher power transmission to take place in order to reach the coverage together with the data rate that we are targeting.
Other questions? Yeah.
So for the 5G communication, like we know like a millimeter wave is a trend, but I'm wondering like how do we solve the penetration issues for millimeters? Is the current technology good enough, like beamforming, or any new stuff need to be developed to address this issue? Because that's a key problem, especially in the city and with high building, bridge and all those stuff. So how to solve that penetration issues?
Sure.
Okay,
Or Wilhelm?
yeah. Okay, I can probably talk a little bit. A very interesting question indeed. That's a big problem, especially going to higher frequency. Interesting thing is, I had the best answer I heard on this question is, you can turn that into opportunity. Maybe for entrepreneurs you have here in this room, maybe this is an opportunity for you to design invisible relays you can probably integrate into your windows or into your walls going forwards. You can relay the energy you receive outside and then broadcast inside. But that's certainly one solution. But there's always this problem is an old problem, not a new problem. We have indoor coverage problem today, right? So I think it's going to be a combination of multiple things. We will try to improve beamforming capability to make this penetrate further. We can use other methods. For example, we can repeat the data frames in cases where you really need that additional 3 dB or 6 dB coverage. That's kind of what we're doing today, actually, in LTE. We have some study last few years for that. But there's also other technology to complement that. You can build indoor DAS networks, in areas you really need very dedicated support for indoor coverage, like shopping mall scenarios, enterprises, and so on. So you don't really have to depend solely on the outdoor network.
So one thing when we were talking about the millimeter wave, you're right, you're not going to have the same kind of penetration, or the path loss is so much more. But because you're operating at such a high frequencies, and talking about the antenna elements, Charlie alluded to it, right? Now everything is getting much physically smaller. And from an antenna perspective, I think there's an opportunity there to really have some advancements that weren't previously available, because structures got too physically large. You couldn't do more than, whatever, a 6-foot or 12-foot type antenna or whatever it was. But now you can do some very highly directive antennas. So what you're losing in the path loss, you could potentially regain back in directivity of your antenna to try to balance things out. The one thing that I think that has to advance here is the processing power in order to do some of these techniques for the beamforming and such are going to be starting to expand probably by an order of magnitude. So there definitely has to be some advancements there in order, efficiency in the processing side, in order to make sure that you can handle all these complex situations and get it done.
Well, I think we're going to end with one last question. 5G is definitely getting a lot of hype right now. Most of it is positive, and it's the industry's shiny new thing. I want to end, however, with by tempering that a little bit and ask each of you what you think will be 5G's greatest weakness. Is it spectrum characteristics? Is it the expense of putting in these systems, complexity, engineering difficulty? There's a whole list of possibilities. Anybody want to start? Wilhelm?
So I would not call it a weakness, but a challenge. And so I think the engineering complexity is, of course, very high because you have such a heterogeneous system at the end of the day with this machine type communication, ultra dense networks, millimeter wave, and Internet of Things and all that stuff. So I would think complexity is the biggest challenge for the overall system. For millimeter wave, it's antenna and hardware, in my perspective.
Yeah, I think one of the more challenging aspects is that migration as we go from 4G to 5G. We're going to be in that ambiguous zone at some point in the future, some 5+ years down the road, where it's, do we invest more in advancing 4G technologies? Do we put our money into the 5G technologies? And there's going to be two different schools of thought, and there's going to be a lot of debates going back and forth on that front until it's sort of the needle swung all the way to the 5G front. So I think that's going to be one of the challenges that are forthcoming in the years to come.
Charlie?
Yeah, so definitely there's many challenges as we discussed today, right? From the business case, from the technology, spectrum. But I think spectrum right now is one of the areas I think I do see some challenge. If you think about the life cycle, the number of years that's needed for technology is very long. We talked about 4 or 5 years. It's even longer when you talk about spectrum, and we are not even started yet in this area. We have a few regulation bodies like FCC or Ofcom in UK started working on this area, but on a global scale, we will not start discussing about above 6 gigahertz until 2019. So that's one of the challenges I see, that we will experience this interesting situation for the next few years. We'll start talk about technology, we'll start talk about channel model, system design, but we still have this uncertainty of which spectrum will be used for 5G. So that hopefully we'll work together to find some solution for that.
Great. Well, I think that wraps us up. Andreas? Thank you all so much.
Thank you, guys.